Bismillahirrahmanirrahim. Students, we have 15 lectures of discrete mathematics. So in this lecture, we will discuss about nested quantifiers. So what is nested quantifiers? Nested quantifiers mean two quantifiers are nested if one is within the scope of other quantifiers. For example, for all x, there exists y such that x plus y equal to 0. Students, we have already discussed that for all mean it is universal quantifier, and there exists is the existential quantifier for some elements. So for all x is a quantifiers, and within this scope there is another quantifier, there exists y such that x plus y is equal to 0. So students, it means for all x, if we have domain real numbers, so for all real numbers, there exists at least one numbers such that x plus y equal to 0. It is a true predicate statement. Predicates, so we know that it is also a nested quantifiers, because there is two quantifiers. Second one is within the scope of first one. So multiple quantifiers, we can say that nested quantifiers are multiple quantifiers. um, for all x there exists y. Pxy means, students, here it is showing the predicate function. So for all x there exists y. In English we can write this such that x plus y equal to 0. Is it true or not? It depends upon the statement, but it is confirmed that it is nested quantifiers, and already it is true because for all real numbers, there exists at least y such that x plus y equal to 0. So another statement, there exists an element for all y. I told you that our domain is real number. So there exists at least one x such that for all y, predicate statement is our true, because there exists x for all y such that x multiply y equal to 0, because at least one element exists for all real numbers, and 0 is the element which exists for all real numbers such that x dot y equal to 0. So order of quantifiers is matter, students, here, because if we change the order, then it is not equivalent to first one. There exists x for all y, and for all x there exists y are not equivalent, because there exists x mean there exists one element for all y such that predicate function becomes, and for all x mean it is universal quantifier. So for all x mean there exists some element such that predicate function is like this. So above statement, in above predicate function, for all, there exists an element x for all y. For all y there exists an element such that x plus y equal to 0 is false, because for all y there doesn't exist some element that x plus y equal to 0, an element. So it is false, because if x plus x is 1, y is 2, so y 1 plus 2 is not equal to 3. Here in this predicate function, it is saying that in this predicate function it is saying that there exists an element x for all y that's equal to 0, that is false. And in below statement, students, predicate function, it is saying that x plus y equal to 0. For all x there exists y, and for all x there exists some element y such that x plus y equal to 0, because if our domain is real number, that for all real numbers there exists some element y such that x plus y is equal to 0. It is true, students. So if we want to negate the statement, nested quantifiers, so recall negation rules for single quantifiers. Not for all x px equal to there exists x, not all, for all will change into there exists x, not that predicate function. So if there is not there exists x px, it will change into for all x, because there exists will change into for all x, not px. So essentially you change the quantifiers s and negates what it's quantifying. Example is here, not for all x there exists y, px y. So it's equal to not if we not pass inside the multiple quantifiers, so there exists x for all y not predicate function, and there exists x not first there exists x, then not there exists y, then predicate function. After that, in second time there exists x for all y not px y. So another one is not for all x there exists y, for all z px y z mean there exists x, then not will pass on to second quantifiers, then not there exists y for all z px y z. In the same way there exists x for all not y for all z px y z, and then after at last there exists x for all y, there exists z not px y z. This is our predicate function. So negating multiple quantifiers, consider not for all x there exists y pxy mean there exists x for all y not pxy. The left side is saying for all x there exists as y such that p is true. P is our predicate function. To disprove it, negate it, you need to show that there is an x such that for all y p is false, right? Because in first in left side we are saying that for all x there exists y pxy, and on right side there exists x for all y not pxy means p should be false on right side. Consider another statement is not there exists x for all y pxy, that's equal to for all x there exists y not pxy. So the left side is saying there exists an x such that for all y p is true, you know. But to disprove it, negate it, you need to show that for all x there exists y such that p is false. So in next lecture we will discuss about translating between English and quantifiers, and we will take some exercise from Rosen books. So today is enough in this lecture. Inshallah, we will come again with new lectures from some exercise from the Rosen books. Thank you very much.